Hello, I'm Luca Morelli, systems engineer with VMware working on networking and security technologies. Today I'd like to tell you about how the integration between NSX and Airwatch generates a quite interesting use case about the end-to-end protection from the device to the services running into the data center. Let's start from the device piece. Like many of you out there, I've been using corporate apps on my mobile device for some years now. I remember at the beginning the experience was quite painful, especially when I had to run, let's say, an enterprise application to access data into my company data center. I had to access that using a VPN client. Obviously, when you have to use a VPN client, you have to launch a client. Most of the times you have to launch a separate application to generate the token, copy the token into the client, start the VPN, and there will be a single device-wide VPN instantiated for the connection. The thing is that most of the times, at least in my case, but I'm pretty sure in most of the cases, there are not just enterprise apps on that device. There will be also some personal apps, maybe your kids' applications. So something which is not very good is the fact that inside the same tunnel, you will have the same level of segregation, the same level of security for both enterprise apps and personal apps. At the same time, I remember I had to use from time to time the profile. I had to update the profiles. I have to manage certificates. So at the end of the day, it was not a great experience. With the Airwatch, we introduced a new feature called per app VPN. I'm pretty sure you already understood what it means given the name. That can associate dedicated VPN tunnel to a specific application. In order to run this functionality, we need a new role inside the data center, which is called a tunnel server. The tunnel server will run, of course, behind your internet firewall. And it will terminate the VPNs starting from your devices, from each single application. This way, we can solve at least a couple of issues. The first one is about the segregation of different applications running on the same device. And the second one, which is not less important, is about the user itself. The user won't have to manage the VPN client. The user won't have to manage certificates and profiles. And at the end of the day, we'll have hopefully a happy user on this side. Well, with this functionality, we solved, let's say, half of the problem. Let's look to the other side of the coin. We have the data center. We have our security admins. Of course, they need to provide the best postures for the applications in terms of security, in terms of compliance. At the same time, they need to bring application to the market in the fastest possible way. And at the same time, hopefully, they will let the user be happy. This is not very easy most of the times. Why? Because if we think about the single enterprise application that from the device accesses the data center services, if we don't apply the right security policies, when the application lands on a single subnet, it will be free to communicate with all the other services running on the same subnet, on the same VLAN. Usually this is not an issue, but if something bad happens on the application side, think about malware or a corrupted application, the malware will be free to propagate inside the data center. And this is something that obviously we want to avoid. Let's think about what we can do on the data center side. Obviously, we'll have a perimeter firewall checking the north-south communications. The tunnel server will communicate with the data center on a specific subnet. This one, for example, 10.1.1.0/info. And to solve the problem that I just outlined, obviously we can leverage solutions such as NSX. NSX brings its main use case, which is microsegmentation. Microsegmentation is the possibility to associate a firewall, a micro firewall instance, to each single virtual NIC of each single virtual machine running in your data center. This means that each workload becomes its own security perimeter, because any connection incoming and outgoing from the virtual machine will be protected by that firewall, especially the ones propagating, running in the same VLAN, in the same subnet. We can segregate the traffic and inhibit the communication inside the same broadcast domain, which is something not very easy to accomplish with other solutions, with other approaches. Let's see how this integration works with NSX and Airwatch. So first of all, we have to think about the security posture, how we can microsegment our applications, our services. I would say this is the most complex piece of the story, and it would take a lot of time to go deep on this kind of topic. When you want to have a microsegmentation applied in the best possible way, you have to have a very granular knowledge of the flows inside your data center. In most of the cases, this is not true for the customer I usually work with. They have very high level visibility, and they usually don't care about what happens in terms of east-west communication in their data centers. Obviously, VMware has a solution for this. It's called Network Insight. Network Insight is a platform that collects all the information through IPFix coming from the virtual distributed switch of the vCenter, and builds some maps in terms of connections or communications between different logical constructs inside the data center. Could be VLANs, could be subnets, could be other constructs. With these maps, we can also achieve some recommendations regarding the microsegmentation rules that we can apply on NSX. Network Insight is not really in scope for this discussion, so I will invite you to have a look at the lightboard from a colleague of mine about networking and operations. For the sake of simplicity, let's design a very simple, let's say, service that our device has to access. In this case, we can assume that we have some intranet services, some, let's say, customer data, and some secret data. In NSX, we use the concept of a security group. The security group is just a set of virtual machines that are grouped according to some common policies that will then apply to that specific group. So for example, we are going to create the security group intranet, and we are going to associate to this security group a given set of virtual machines. The same goes for the security group customer data, where we have some other VMs. And exactly the same for the secret data security group, where obviously we are going to put the VM51. Now, at the same time, we have to define the security group to which our application belongs. We're going to call it security group CRM. And you're going to see how we can associate this group to a specific application on the device. So first of all, in order for the integration to work, we need to configure the content of this group. We have simply to associate an IP range to this group. In a while, we'll understand why we have to do this operation. In NSX, we call an IP range an IP set. In this case, the IP set will have to belong to this subnet, the subnet over which the tunnel server communicates with the data center. We can, for example, use the 10.1.1.10/30. So we'll have some addresses available. And something very important that we need to specify is a tag, Airwatch tag, inside the description of the security group. Okay. Obviously, all of this is managed by the NSX manager through the GUI or even the API. Once we decided how to group our application, we need to decide how to configure the policy, the access of this application to the rest of the data center. So for example, we want our CRM application to access the internet data. Obviously, we want it to access the customer data, but we don't want it to access the secret data because it's secret. Okay, so we have a very simple example of how security posture could be designed. Thanks to this small tag, we are going to have this group available for the Airwatch console manager. The Airwatch console manager will communicate with the NSX manager through API calls. Is going to retrieve all the groups, all the security groups with that specific tag specified, and we'll make it available. We'll make it available for the operator, and the operator will be able to associate the CRM up to the security group CRM up. Now that we configure this association, what's going to happen? The user will launch its CRM application. A perhaps VM tunnel will be instantiated. A tunnel will be created. It will be terminated on a tunnel server. The tunnel server will understand the association between the CRM application and the security group on the NSX side, and will instantiate a source IP address for that specific application. How is going to decide the IP address? Well, he's going to average this IP set. It's going to take the second valuable IP address in that range. So in this case, the CRM application will be presented with an IP address of 10.1.1.11. Okay. Something very important is that if we want to understand how it works for additional users, we simply add the device to the picture. The second user will have its dedicated tunnel for its CRM app. And as soon as the tunnel server will receive the communication from the second user, it is going to instantiate a connection to the data center with exactly the same IP address. What's going to change is the source port. An ephemeral source port will be instantiated for each single user. This way it is going to be possible to track and monitor the different connections. Now, why we want to source NAT to instantiate the connection with this IP address? Because thanks to this IP address, the connection will be associated to this security group. And then all the policies associated to this security group will be in place. So the connections coming from the CRM applications will have connectivity to the intranet security group, will have connectivity to the customer data, but don't have connectivity to the secret data. And we applied a microsegment model to the single application. Let's try to understand how it works with additional pieces in the picture. Now, first of all, we might want to scale this deployment. Two main reasons would be to have a higher number of users, or even if we just want to provide high availability. So we'll have two tunnel servers, first one and the second one. What's going to happen is that we are going to need a load balancer here. The load balancer is going to receive connections from all the devices and is going to distribute according to a specific algorithm the connections among the available servers. The tunnel server will instantiate connections on the same subnet. What's the difference? The second tunnel server is going to use the next available IP address from the IP set, which means that in this case, the CRM application will be sourced with a 10.1.1.12 IP address. In such a way, it's going to be associated to the security group, and the same security policies will be applied. Okay. Same goes for the source port. It will be an ephemeral port. It will be unique. It will allow to track the user and the connection from a single device. Let's try to make it even more complicated. What happens if we want to work with an additional application? It could be, for example, a Chrome application, browser. Obviously, it is going to instantiate a VPN connection that is going to be distributed to the tunnel servers. And obviously, we'll need to configure a security group dedicated to the new application. We'll have something like this. We'll have a security group Chrome app. We'll have to configure an IP set. That could be, for example, 10.1.1.20/30. We'll have to specify the Airwatch tab as we did before. And obviously, we'll have to make sure that the right policies are applied. So for example, in this case, we don't want the Chrome to access customer data. We want it to access the intranet. And as usual, we don't want them to access our secret data. Okay? This information is going to be available on the NSX manager. Given the fact that we have the Airwatch tag, it is going to be retrieved by the Airwatch console and will be available for the operator. The operator is going to associate the Chrome app to the security group Chrome app. This way, as soon as the application is established, the tunnel servers are going to make a new association, to make a new source NAT from the Chrome app using the second available IP address, 10.1.1.21. Same goes for the second tunnel server. Then 1.1.1.22 in this case. And we can extend this to additional devices and even additional applications. With this, we are going to have a first level segregation with the per app VPN functionalities on the device. We are going to distribute these connections on different tunnel servers, and eventually we are going to segregate these connections inside the data center with a microsegment model. In such a way, we can limit the scope of the communications inside the data center, and if something goes wrong, we're going to stop any kind of unwanted propagation inside the data center. Hopefully with an happy user and with an happy security admin. Well, I guess that's it. I hope this was useful for you, and I thank you for viewing. Arrivederci.